So let's say they ask you to simplify this one for 4 marks. Now, the first thing you do here, you write the first one as it is, 3 to the 2x plus 1. Then you come to this 15. You realize that you can't write 15 in exponential form, but the best you can do is to write it as a product of its prime bases. So that's what you do. Then you say everything is divided by what? So 27, we understand it's 3 to the power 3. So here you have 3 cubed, which is further raised to the x minus 1. You write the 3 to the x as it is. You write 5 to the 2x minus 4 as it is as well. So even in the numerator, you still write 3 to the 2x plus 1 as it is. And then when it comes to this one, you understand that the exponent of 3 and of 5 are both 1. So you say this exponent multiplied by the whole thing, this exponent multiplied by the whole thing. So this means you'll have 3 to the 2x minus 3. Then you say times 5 to the 2x minus 3 as well. And then you say the whole thing is divided by what? So here you distribute your 3. So you're just going to have 3 to the 3x minus 3. Then you say times 3 to the x. And then you say times 5 to the 2x minus 4. Then you focus on the numerator. You apply the first law of exponents to these two. So you say when multiplying powers of the same basis, you add the exponents. Now 2x plus 2x will just be 4x. And then 1 plus negative 3, it's the same as 1 minus 3. So it's negative 2. Now this one, you write it as it is for now. And then you say the whole thing is divided by what? Now, even here, you apply the first law of exponents. When multiplying powers of the same basis, we add the exponents. So 3x plus x will just be 4x. And then you say minus 3. Then you still say times 5 to the 2x minus 4. Now, instead of applying the second law of exponents to both of these, because it's going to result in a mess, which most people don't appreciate anyway, let's reverse the first law of exponents for all 4 of them. So you say, before it became this, it was once 3 to the 4x times 3 to the negative 2. Then you say times. Before it became this, it was once 5 to the 2x times 5 to the negative 3. And then you say the whole thing is divided by what? Before it became this, it was once 3 to the 4x times 3 to the negative 3. And before it became this, it was once 5 to the 2x times 5 to the negative 4. Then from this point, you see that these ones will simply commit suicide. And then you are left with the numbers. Then you can safely apply the second law of exponents for both of them. So you say when dividing powers of the same basis, we take one base and then we subtract the exponents. So this is what you say. Now, negative times negative is a positive. Negative 2 plus 3, it's positive 1. So you have 3 to the power 1, which is just 3. Then you say negative times negative, once again, it's a positive. Negative 3 plus 4, it's positive 1. So you have 5 to the power 1, which is just 5. Now, 3 times 5 will give you a very nice 15. And then you should be happy with this one. Let's look at another one. So let's say they ask you to simplify this one for 5 marks. So it's 8 to the power n minus 3. Then you say times 32 to the negative n plus 1. Then you say times 6 to the 2n. And the whole thing is divided by what? By 9 to the power n. This is what we have. So the first thing we do here is to make sure that 8 is written in exponential form to base 2. So we say it's 2 cubed, which is all raised to the n minus 3. We make sure also that 32 is written in exponential form to base 2. So it's 2 to the power 5. The whole thing is raised to the negative n plus 1. Now, 6 cannot be written in exponential form, but it can be written as a product of its prime bases. So this is what we have. And then we come to 9. We write it in exponential form as well. So it's going to be 3 squared, which is raised to the n. So we can say it's 3 to the 2n right away. Then we come to this one. We distribute the 3. So then we have 2 to the 3n minus 9. Then we come back to this one and distribute the 5. So we have 2 to the negative 5n plus 5. Then we say times. We know that the exponents here are each 1. So 1 times 2n, 1 times 2n as well. We get 2 to the 2n times 3 to the 2n. And then we say the whole thing is simply divided by 3 to the 2n. This is what we get. Well, we can see that it's only one term in the numerator, so these two can safely cancel out. Now, we focus on these twos. We can apply the first law of exponents right away. So when multiplying powers of the same basis, we take one base, then we add the exponents. So it's going to be 2 raised to the 3n minus 9 plus negative 5n plus 5. And then we say plus 2n. This is what we get. And this bracket is not necessary, by the way. So it's like you are having 3n minus 5n, which is negative 2n. Negative 2n plus 2n will just be 0. So we don't have the n's anymore. But what about for numbers? So it's negative 9 plus 4. It's going to, sorry, negative 9 plus 5, it's negative 4. So this is our answer. It's 2 to the negative 4. But you can't leave your answer in negative exponential form, no? So what are you going to say then? When you write it in positive exponent, it's 1 over 2 to the power 4. But what is 2 to the power 4? It's just going to be 16. And this is your very nice final answer.